Hello people! In this video I'm going to go over the conversions between YUV and RGB. So before we get started on building a program, let's take a look at what YUV is. YUV actually goes back to, the history of YUV goes back to the old CRT TVs. So TVs used to be in black and white, and all that you would have to do to send a signal to it is the signal just had a brightness value. And once we wanted to add color to TVs, we wanted to have backwards compatibility, and so we added a couple more signals which added color. So the original brightness signal remained the same, and then we had two other signals which we're able to encode the color that we want. And so that's essentially what YUV is. It's an analog system, and that's how color TV works. Now in our computer world, our digital world, we have actually something called YCbCr, which is essentially the same as YUV, except it's a digital version of it. And so what we're going to be doing today is to write a little conversion between YCbCr and RGB and back. And if you want to see what the format is for that, you can actually go to this URL and read this document. In fact, if you scroll down, they actually have the conversion formulas for you. So they have conversion to and from RGB from the YCbCr values. And that's what we're going to be using in our program today. So let's just go ahead and get started. And let's just, in our workspace, let's create a directory YCbCr. And we will change our directory. And we'll create, let's just call it main.go. Oh, we'll be doing this in the Go programming language. If you don't have it installed on your computer, you can look at a previous video I made on how to install and set up your programming environment. So with our program, in the beginning of our program, let's create a main. We'll have the main package, and we're going to import. What we're going to do is we're going to write our own version of the conversions, and then we're also going to import the Go's standard library version, and we'll compare our version against the standard libraries version. So let's go ahead and create a main function, and here what we'll do in main, we'll write our test program. But for now, let's go ahead and write our functions for RGB to YCbCr. We'll have R, G, and B, and those will be unsigned integer 8 bits, and we're going to return 8-bit unsigned integers, 3 of them. That will be our RGB value, and we'll also have a YCbCr2 RGB. Too many letters. And then we'll give a Y and a CB and a CR, and those will all be uint 8s. And we will return uint 8s. All right, and those will be our two functions. So let's just go ahead and start writing it. So what we're going to do is let's create some, let's convert our unsigned integers to floats. There's actually for efficiency purposes, there's actually an integer way of doing this, but we want to make it I want this example to be as simple as possible, so let's just convert our inputs to floats. So let's just do float 64, that'll be nice, and we'll convert our R value, and we'll have our G value be a float 64, and our B value will be a float 64. And after we convert them, we can now create our Y value, which will be 0.299 0 times R1. Oh, and by the way, where I'm getting these constants from is right here. Whoops, right here. So this is the Y and the CB and CR value. So we're going to do the exact same thing here. So let's do, so we multiply by R1, and then we have 0.5870, and we'll multiply that by G1, and we add 0.1140 by B1, and that takes care of our Y value. So then we'll create a CB value, negative 0.1687 times R1 minus 0.33113 times G1 plus 0.5 times B1 plus 128. And we'll do finally have our CR value, which will be 1/2 times the red value minus 0.4187 times the green value minus 0.0813 times the blue value. And we will also add 128 to that. And then we will return 8-int integer versions of this, of the Y, CB, and CR values. So for the YCbCr to Rgb, let's do the same type of thing. Let's create, let's convert to float 64 for the Y, and CB1 will be float 64 CB, and CR1 float 64 CR. And now we will create our RGB values using the conversions outlined in the document I showed. So let's just do Y1 plus 1.402, and we'll multiply that by CR1 minus 128, and our G value will be Y1 minus 0.34414 times CB1 minus 128, and we will subtract 0.71414 and multiply by CR1. Let's see, CR1 minus 128, right? Y1 plus 1.772 times CB1 minus 128, and that's it. Let's return uint 8 for red, uint 8 for green, and uint 8 for blue. All right, so now we've got our functions built. Let's go and create our test function. So first, let's create some YCbCr values. So let's create a uint8, let's say 200, CB, uint8, 150, and CR value, uint8, 150. Let's do that. All right, so let's create our R1, G1, B1. We're going to create results. We're going to do a conversion to RGB, and let's use ours first. So we'll do YCbCr to RGB, and we'll give it the Y and CbCr. And then we'll have an R2, R2, G2, B2, and we'll use the built-in version, which has the same name, YCbCr to RGB. Let's see, RGB, and then we'll give it the YCbCr, and let's print out the difference. So let's do a print line, and let's do let's just say my function, and the R value will be this, G value will be that, and B value will be that. And we'll go, let's not do a print line, let's do a print F. Okay, so then we can say, let's do, ours is R1, G1, and B1. Then we'll do printf, and we'll do built-in. Whoops. There we go. And it will have a red, green, and blue. There we go. And that one will be R2, G2, and B2. Okay, so let's create an RGB value. So this is a test. Say this is test the YCbCr. Let's see, functions. And here we will test RGB functions. I guess they'll be conversion. Let's do this. Conversion. Okay. So let's create an RGB value. So RGB uint8, we'll say 255 for the red value. Green value will be uint8. Let's do 150, and a blue value of uint8 100. There we go. And we'll do the same thing. We'll have Y1, CB1, and CR1 will equal our RGB to YCbCr, and we'll give it RGB. And then we'll do a Y2, CB2, CR2, and we'll do color.RGB to YCbCr. We'll give it RGB values, and then we can print out our results, printf, and we'll say my function. We'll do Y and CB and CR. Oops. Let's see, there we go. And then we'll do a Y1, CB1, CR1. printf, and we'll do built-in YCbCr, and we'll do Y2 CB2 CR2, and that's it. All right, if I haven't made any mistakes, it should run. So let's do a go. Always good. It's always good to format your code using gofumpt. And a lot of people have editors where it automatically uses gofumpt upon saving, but I just don't have that set up right now. So let's do go. I think it's gofumpt -w or -w, and then give it the name of your file, and it will just overwrite the file and make sure that it's formatted properly. And then we'll do go run main. Let's see how that goes. Undefined. Oh, maybe I did a yes, I did. I made a little mistake. So of spelling. So let's go to line 26. There's too many T's here. Okay, so let's try that again. What? Undefined RGB to CB. Oh, yeah, that's right. I need to. 26 needs to be Y, not T. Insert Y, right? There we go. So for this one, our function got 230, and the built-in one got 231. The green got 176, 177, and 238, 239. And that's okay because it's just difference in rounding. So it looks like it works. And then for our other function where we convert from RGB to YCbCr, we got 175, 176, that's good. 85 and 85, that's good. 184 and 185, that's good. So we know that our conversion function works. So that's about it. So that's how we do conversion. So you may not encounter this very often in your normal programming, but maybe you want to build a program that where you want the user to mess with things that mess with properties that deal with human perception. Like maybe you want to reduce the brightness or saturation or something like that. Then you can use this version rather than RGB, and then convert it to RGB for your screen. So it's kind of useful for that kind of thing. So that's all for today. Thank you for watching. Till next time.